Now we're going to explore a couple of functions which are designed for complex numbers, dealing with complex numbers, and how we can work with them. Before I further explore this part, I would like to explain the identity I itself. So as you remember, I comes into place when we're dealing with a square root of a negative number. So we had, like, if you had a sqrt of 5, we're totally fine. But if we change that, then a complex number will be created. A sqrt of -1, if you hit that, it's totally equal to I identity. So this stuff, we knew it. Just wanted to give you a brief review about it. Let me clear up the screen. In order to illustrate the multiplication, division, and like taking numbers to power, let me define two variables. Let me define a, 3 minus 1, 3 minus I, and then b equals 7 plus 5i. Okay, so I defined two different complex numbers, and now I can easily do a multiplied b, a minus b, and a divided by b. And as you see, MathLAB has no problem dealing with this type of info. Something which might be new is a raised to the power b. And if you hit enter, you see that MathLAB also can calculate it without any problem, and well equipped with different functions for you, so you can try out different modes. So let me clear up the screen, and now we're going to investigate new formulas that we're going to learn to deal with a complex number. The first one is apps. So if you remember previously, when we have a number, let me define a new one. Let's see, equals to 2, and also d equals to -5. All right, so I defined two new variables. One is positive, the other was negative. Now, if I do apps of d, the result is going to be 5. And what it does, as we know, it just makes this positive. But how about if we type apps of a? And if you remember, a is a complex number. It has a value for real part, it has a value for complex part. So it would be great if, let me do this, if I type a first, so you kind of know what we're dealing with. And then if I type apps of a, what it does, as you see, it just returns out a single number. And what it does is that takes the real part, the square of that, and then the imaginary part, raise that to power 2 as well, and adds these together, the squared parts, of course. And then sum them together and take the square. So this one is going to be 9 plus this one is going to be 1. 9 plus 1 is going to be 10. Then if you take the square root of 10, it's going to be this number. So from now on, we know that if we return a complex number into apps function, it's going to bring us the magnitude of that complex number. The magnitude is the same way if we type angle. If we type angle of a, so what it does, it just returns the angle between the complex number and the complex part and the real part. And the same, it is the same as trigonometric. It's now in radians. So if you want to try that into degrees, what you're going to do is to multiply this by 180 and divide by pi. So if you do that, now the result is in degrees. This is going to be in degree. Let me clear up the screen. So we learned about the absolute value. We learned about the angle, which defines the angle between the complex and real part. The next one that I would like to talk about is a function called real. So if I type real and say, before that, let me type b here. Now this is b. If I type real b, as you might guess, it will bring only the real part of it. Or real a. If you remember, the real part was 3. The same we can do imaginary. So the function to deal with that is imag. So if I do that, image of b, it will return the 5, and image of a is going to return the minus 1. So these are some functions that we need. You might ask, why do we need all this stuff? You know, there are a lot of problems that you need only, let's say, the real part to do some calculations. So you want to compare only the real part of two complex numbers so we can extract them and then compare them, or do some sort of other calculations on the extracted parts. And these are really, really important functions. So let me clear up the screen. And one more function that I would like to talk about here is conjugate, okay, complex conjugate. So if I have A, and you know that the complex conjugate is the same number, but with the different sign for the complex part. So if I say conjugate of A and hit enter, you see that the same thing is returned, what with the different sign. And I can do it with the B too, and it will do that. What could be interesting for you to know is that I can do the same, I can get the same result. If I put B and then single quotation, I get the same result. A was this, and the conjugate of A can be gained that way too. Before I close this part, let me introduce the last one. So there are occasions that you want to create a complex number with a specific part of real and a specific part of imaginary. So the way that we do is like doing this, 4 minus 6i, okay? So I created this way. But if you remember, just minutes ago, I explained that sometimes you kind of extract a part of a complex number and store it somewhere. Extract a part of another complex number and store it somewhere else. Sometimes we bring these together to create a new complex variable. Let me show you how to do that. There is a function in MathLAB called complex. So if I type complex and type 3 and 9, it takes 2 arguments. And if I do that and hit enter, you see that it creates the first one, it creates the real, and the next part, it just creates imaginary part out of it, adds them together to make one single complex number. These were some few functions that are very common when dealing with complex numbers, and you're supposed to work with these and kind of be confident when using them. See you in next part.